mouse to do what I want to do. So chapter 4 is looking at graphing, and in part of chapter 4 we need to take a look at what's called the coordinate system. And what that is, I guess I probably better have a fatter pen than just that one. Sometimes it shows up with an ink pen and sometimes it doesn't. So in graphing, we have two lines that end up crossing each other, and these are called axes. The axis that runs horizontal is your x-axis, and that's where you locate all of your x values or your x point parts of your coordinate system. The other is your y-axis, and the y-axis is of course where it ends up crossing those two, and it comes together at what's called the origin. And the origin is a value of 0, 0. So it's where the two lines end up crossing each other. It's like having two number lines because x is labeled 1, 2, 3, 4, 5, 6. The opposite direction is a -1, -2, -3, -4, -5. So one's a positive direction, one's negative. At y, same thing, it's negative going down, and it's positive going up. And so when you got those in there, that's your values. Now, will you see all these all the time? It doesn't number them out on your graphs in Hawks. It will maybe put the 5 values in and leave it at that and not put all your other ones in. But you know that in between there are different numbers and different values that do fit into there to find. Within this, there are quadrants, but your quadrants go in counterclockwise of each other. And the reason we have those is because each one has certain things that occur in it. And the certain things that occur in each one of these is the fact in quadrant 1, if you look at your x's, they're all positive. If you look at your y's, they're all positive. So every point that sits in that quadrant is going to have positive values to it. So in this quadrant we might have 2, 5. And so what you would do to plot this, the 2 is in your x position, location I should say, and the 5 is in the y's location. So we go over 2, because you go over for your x, and your 5, you go up for 5, and you simply put a dot in that location where that happens to be. So in Hawks, with your cursor, you would go over 2, up 5, and hit your enter to enter that piece so that you get that dot located in that spot. Okay? So you're not doing it on paper. You're going to end up finding it when you locate it in that position. So then in quadrant 2, if I go across it, what do I notice? Well, I notice all my x's, and x always comes first, and my y's, x's are negative, y's are positive, and that's all you'll ever find in that quadrant is your point value. If it starts out as a negative x value and a positive y value, it's going to always be in quadrant 2. Quadrant 3, what do we know about it? Both are negative. Because x's are negative and y's are negative, so both things are negative in there. So we got the negative values that are sitting in that spot. And the last quadrant, which is quadrant 4, what do you know about it? Well, if I look at x's, they are positive. If I look at y's, they're negative. And so therefore, when I look at those quadrants, that's the pieces that I know that ends up fitting into that. And that's what happens to come out of that, so that I know of all my pieces and what I happen to have. Now, if you have a point that sits on an axis, if you have an x-intercept, that is a point on the x-axis. So it's going to sit right on the x-axis. And how would I find? Well, if I said I had an x-intercept and it's set right here at 3, what does that tell me about that x-intercept? Well, it tells me that x is 3, but where have I moved? I haven't moved anywhere, so y is 0. Okay? Every x-intercept will have an x value, but y will always be 0. So x will be some number, but y is always going to be 0. It will never change. So it's always going to be the same thing. And we'll get into more of that in 4.2 when we use the intercepts to do our graphing with and coming up with what those values are. If it's a y-intercept, it's going to sit on the y-axis. So if it's right here at a -3, what does that mean? Well, what have I done with my x's? Have I moved anywhere on x? No. So x is 0, but y is some value that I happen to have. So then in this case, for a y-intercept, x is going to be 0, but y can be any number that it needs to be a y-intercept. So it's going to cross at that. So x is equal to 0, and y is going to equal some number. And so you've got a little difference going on there between x and y-intercepts. But again, this is on the y-axis, and this one up here is on the x-axis. So if you've got those type of things happening, your x-intercepts are always on x, your y-intercepts are always on y. And that's basically all our points we can have. Can we have fractional values? Yes, because you have to estimate with those. So if you were given a -1/2, 2 1/3, where would that be? So I would find a -1/2, so I estimate a half. And what does the other one tell me to do? Go up or down? Go up 2 1/3. So that point is right here. It's not really on anything. It's kind of sitting in the middle. Whoops. It's sitting in the middle of things. It's not really into that location at all, because I estimate my half, go up my 2, and then estimate a third and put a dot in that location. Now in Hawks, again, it's the estimation. As you put your dot over to here and you raise it and go straight up above, when you click your enter, it will put a dot at that location, right? And so you are going to have some fractional values in there that you're going to have to plot when you start looking at plotting points and coming up with those. Okay? What do you think? So far so good? So far so good? Okay. So what they will ask you to do in Hawks is to plot some points. So if we had the point -2, -4, where is that at? So I would go across on my graph paper and find quadrant 3, so it's going to be somewhere down here, right? So I would go over 2, because it's negative, and down 4, and stick a dot right there, and I'm done. Okay, that's what my graphing part does for me. Now where do you see coordinate stuff? A lot of times in maps. If you're going to find a city, the Michigan map or any map that you run across has sides to it. The only thing with the Michigan map is it works with one quadrant. It will label one with numbers and it'll label the other one with letters. And you might locate a city and it's at C9. So you would go across and find C on your map, run your finger up until you found 9 running across, and that city would be somewhere near that location. So you still do quadrant stuff with when you get into mapping and so forth. So this was quadrant 3. How about this one? -4, 6. Where's that one at? You want to put your whatever you're at. Huh? At 2? Quadrant 2. Okay. And then where do we go with that one?
So, because it's not letting me do it at home. Like I downloaded most of this.
Show me on break. Okay. Right now, pay attention to what's going on. Okay. So where's that? So we were over 4. And we are going to go up 6. And I'm right in my letters up there, but that's where you'd locate that at. Okay? that make sense? We do plot points then? Do a good job on plotting points? Okay. Pardon? Always within this, x is your first value, y is your second. And when you look at these, x is what's considered to be independent. And the reason it's independent is because x can be any value that you want to pick it and choose it to be. Y, in the other case, is dependent, because y relies on x. So once we know what x happens to be, then we can end up figuring out what y happens to be. And so that's kind of what we do with those, and that's when we get around to plotting equations and coming up with what our values happen to be. So we okay with plotting points? I think? Okay. Now, what happens with these is as we work with those, we end up having equations. So this is still 4.1, and they might give you the equation of a negative 3x plus 15 over 7 is equal to y. Now what has changed between what we used to do and what we're doing here is we no longer have one single variable, we have two variables. We have the variable of x and we have the variable of y, which we can have those because when we start looking at plotting some of this stuff, if we can figure out what we put in for x, we can solve for y and it gives me a point on my graph. So in some cases in Hawks, they'll tell you that x is equal to a negative 2 and ask you what is y equal to. So what is y equal to? So what would I have to do? Well, I'd have to plug in a negative 2 wherever x is at and kick out what y is going to be. So what would y be in this case? So 3 times a negative 2 is a negative 6. 15 and a negative 6, what do I get out of that? I think I get a 9, don't I? Yeah. So y is equivalent to 9/7. So what would this mean if I plotted this? I would plot a negative 2 on x, and then I would plot 9/7. Well, can I plot 9/7? 9/7 kind of sounds strange. But if I turn it to a mixed number, 9 divided by 7, I find out that I have 1 and 2/7. So if I have 1 and 2/7, what happens to that when I plot it? Well, if I put my graph back in here and I plot that, I'm going to be at a negative 2, and I want to go up 1 and 2/7, so I want to approximate that. So that's where that point would be located. Okay? So that's my location on that point. And so I know where it happens to set at that point. So then if on the same equation they were to tell me that x equals 5, what would y equal then? So then I would say 3 times 5 plus 15 over 7. And what would I get now? So 3 times 5 is 15. 15 plus 15 is 30. So I get 30 over 7. And if I take 30 divided by 7, I end up with 4 and 2/9, comma 5. If I put it back into its point formation, or 4/7, sorry, not 9/7. Gotta remember what I'm putting in there. So if I plot that one on my graph that I had over here, that means I'm out at 5. 1, 2, 3, 4, 5, and I'm up 4 and 2/7. So 1, 2, 3, 4, and 2/7. And I plot it. Then what I can do is if I connect these 2 points that are in here, I have a graph of my line. So that's what my line ends up looking like. Okay? So I get a graph of my line. So basically I can graph a line with 2 points. But if you really want to graph a line in the format and knowing that you for sure have a line, you might want one more point. Now notice this line is going to cross right there. And where is that? That's a negative 5. 1, 2, 3, 4, 5. So if you pick a point on here where it crosses in the center and plug that number in, so negative 5, if I put 3 times a negative 5 plus 15 over 7, what do I get? Well, I get a negative 15 plus 15 is 0. So I get 0. So when I'm at a negative 5, I should be at 0, and sure enough I am, and so I know I graphed my line correctly. So 3 points will tell you you graphed it perfectly correct. 2 points will give you a line, but if you get 1 point off, you got a line, but it won't be the right line. So always keep that in mind. Hawks has you only do 2 points, but if you get in the habit of doing a third, you will know that you've got that problem done correctly. So do your third point in there, and then you'll know that you do have it done out correctly. Okay? So far, so good? Okay. Another that they do is might give you another equation, y equals 2x plus 3. In this one, they sometimes give you a chart in Hawks, and in that chart you will have x's and y's, and they may give you x is 1, y is 3, and x is 2, and ask you to solve that equation and figure out what your answers would end up being that you would plug in here to represent your different spots. Be careful when it says x, because you're going to put that in where x is at, but when it tells you y, you're going to put y in where y is at. So what would be my values that would go in here? So I would put 1 in where x is at. So 2 plus times 1 is 2, plus 3 is 5. So when x is 1, y is 5. What is the next one? When y is 3. So that means 3 has to go in here. And then I would end up taking that one and solving it for x instead. So I'd minus 3. Divide by 2. And I would find x is equal to 0. What kind of thing is that I just found? It's special because when one of these is 0, it tells me a certain thing. Is it the x-intercept or the y-intercept? Y-intercept, right. Because it's crossing y. The y is the one I have the number on. X is 0, so I haven't moved anywhere on 0. So remember when you did your graphing, you haven't moved anywhere on 0, but you've moved up 3 on y. Okay? So that is a y-intercept, not an x. And if you can identify those, it helps you out a little bit later on because we're going to work with intercepts and so forth with those. And the last one, what's it going to be when x is 2? So then if I plug 2 in, y equals 2 times 2 plus 3. Y is going to equal 7. And so we found our answers that Hawks was asking for, that we were trying to find within that. So you get charts. Not bad. Again, Chapter 2 stuff, because we did kind of the stuff in Chapter 2 where we plugged in stuff and solved for different things. They may also give you ordered pairs. 0 something, 3 something, and negative 4 with something missing up the front, and give you the equation of 4x plus 3y equals 24. So it may say find the missing pieces in these 3 points that you're given for this equation. So same principle. Plug in your 0 where? Where am I going to plug 0 in at? 0 goes in for x. So 4 times 0 plus 3y equals 24. So 0 is here, so 3y equals 24. That's why intercepts are so nice, because everything kind of cancels out. Divide by 3, and I get y is equal to 8. Yeah. So y equals 8. Then if I plug 3 in, 3 is going in for x as well. Three times 4 is 12. Subtract 12. Now you're back into that solving stuff we did back in Chapter 4, or Chapter 2 I should say. Divide by 3. Oops, this should have been a 24. This should be a 12. So y is going to equal 4. And then finally, the last one's a negative 4, and that goes in where y is at. And so 4x, 3 times the negative 4 is negative 12. Add 12. So 24 plus 12 is 36. Divide by 4. So I find x is equal to, what's x equal to? Good old 9. So x is equal to 9. Yep. But be real careful, make sure you plug them in the right locations and the right spots with those. Now, does it make a difference of which numbers you choose? Each line has an unlimited amount of answers that you can possibly come up with. And so you can get into picking out what numbers you want to put in and what ones that you use to solve these with. So you want to kind of pick stuff that works out well. If you run across ones that look like this, where you have a fractional piece in front of x, this is called your slope. We'll learn about that a little bit today too. That's your slope. And so what's in front of x is that slope piece. So what kind of numbers would I want to pick for x? Well, because x is independent, that means I can pick whatever I want. I would more than likely pick numbers for x that will cancel with this too. Because if I can get rid of that denominator, it's going to make my life a whole lot easier. If I put 3 in here and have 1/2 times 3 over 1 plus 2, doesn't make life very easy, does it? Because nothing cancels, so I end up with 3/2 plus 2, which makes it a lot harder to work with. But if I would have put a 4 in there, the 2 and the 4 will cancel, which leaves me with 1 times 2 is 2 plus 2, and I get an answer of 4. Okay? So if I have an even or a number down here as a denominator, I want to pick things divisible by that number. So I want to pick things that 2 will go into, instead of picking 5s or picking 9s or picking something that's odd that 2 will not go into. I want to pick stuff that's even.
So say you did pick 4, and then it would just be y equals 2x plus 2. I don't see how you got 4 for y.
Okay, right here, when I put 4 in,
Right, you get 2.
this will cancel. 2 times 1 is 2.
Oh, you don't even have
2 plus 2, no, x's are gone.
I see.
Yeah, because what you're doing is you're forcing to find out what y would equal when we apply a 4 to that problem.
Right.
Yeah. Then if I would have put in a negative 2, I would have had y equals 1/2 times a negative 2 over 1 plus 2. These still would cancel, but a negative 1 times 1 is a negative 1 plus 2. And so I end up with a positive 1 then. Okay? So when it's at a negative 2, I get a positive 1.
So you can just make up your own numbers?
Yeah.
Yeah, because you want to
Yeah. Yeah. In graphing, you can pick whatever you want for x. That's why x is independent. Independent means it can be anything it wants to be. Okay? Any number that you want to pick out of here and you want to put in for x, you can put it in there. Okay? Then it makes y dependent because y will only be 4 when x is 4. Or y will only be 1 when x is a negative 2. Otherwise it won't. It doesn't end up being those things. So you want to make sure that you get whatever you pick for x, you can plug in there. Now if you pick for y, you're going to still force out an x. Okay, and x is going to come out of there, but sometimes it doesn't show up at that point. The other way that you might see these in Hogs is written this way. And the only difference is just the way in which the chart is running. You still have your missing pieces in here. So you're still taking these numbers that they give you and plugging them into your equation. So y equals 2x plus 1. That means wherever I have an x, I put in a 2. Wherever I have a y, I put in a 4 in my next point. The third point, wherever I have an x, I put in a 5. And the last one, wherever I have a y, I put in a 1. And you'd solve it from there. Okay? But it's just how they relate these charts. They run them this way, they run them up and down in Hawks, just so you know that those are the different kind of possibilities and combinations that you can run across. Okay, questions on that stuff? We okay with that, do you think? Think so?
This chapter's a whole lot better than last chapter, I'll tell you that.
It is.
Oh, man.
Chapter 3 is a rough chapter. Yep, no getting around it. But anyway, that's the stuff that we end up having with our values in there. They also give you Fahrenheit equals 9/5 C plus 32. And they may give you, in this one, instead of giving you X's and Y's, they give you F's and C's, but in this case, mainly C's. So they might give you a temperature of 21 degrees, and you need to find out what F would be. Or we'll put 20 degrees in there just to make it easier. If you put 20 in here, you have 9/5 times 20 over 1 plus 32. What would be my new Fahrenheit temperature? So 5 goes into 24. 4 times 9 is 36. 36 plus 32 is 68 degrees. And they might give you a Fahrenheit temperature of a -5 degrees. What would your Fahrenheit temperature be? So you plug this in for C again. And what would we come up with? Well, 5's cancel. Usually a -1. -1 times 9 is a -9 plus 32. So what does that work out to be?
23.
23. It'll be 23 degrees. Alright? So it's just plugging stuff in and figuring out what your answers are. And that's basically all there is in 4.1. It's just going through, putting in values, and picking out what your answers would end up being. And always remember, your order pairs are in the format of X, comma, Y. They're never in any other format, so they're always going to be in that range or in that level that you're looking at. Okay. 4.2 is graphing equations and plotting points. And the only difference with this one is that now you're going to plot those points. So when you are in Hawks, you're going to find that they will give you a graph. They will give you an equation, such as y equals 2x plus 7. And then they will ask you for 2 points. Now the points that you put in here can be any points you want to pick. So if you have this equation, you can pick whatever numbers you want for x. Does not make a difference. So it's not like you're limited to something. You will want to pick smaller numbers because usually your graph is a 10, and it's got 10 out here, 10 spaces and 10 spaces, and 10 up and 10 down. So you've got to pick something within that. So you might pick a number such as 2, and you might pick the other one as 3, and you would just solve that. So what would I come up with if I put 2 in for x? Or will I be off my graph? 2 times is 4, plus 7 is 11. Okay. If I put 3 in there, what will I get? 6 plus 7 is 13. I might be pushing it there. That one might not be on my graph. So I might want to pick a negative number. So if I pick a negative number, 2 times a -2 is 4. And 4 plus 7, or -4 plus 7 is 3. And that one will be on there. So I plot this by going over 2 and up 11. And you will go over 2, up 11, hit that spot, and hit your enter, and you'll put a dot on your graph. Then to do the second one, I can't do this one, but I'm going to do this one. Over 2, and up 3. And you'll put a dot there, and automatically, Hawks is going to put a line in there for you. It will stick a line in your graph. So then you'll know you've got your straight line. Nope. No, as long as you get your math done correctly. Because Hawks will do this regardless if you, let's say we put 2 in here. 2 times 2 is 4, 4 plus 7, and wrote 10. And you plotted the point of 2, comma 10. It'll plot that point, okay? Then you go over here and you do this point, and you get that one in there, and it draws your line instead of where it's supposed to be. It takes it and it draws it like so, okay? It'll put this line in there, and then it's going to come back and say, it's not right, okay? So if you do a third point, such as if we did a negative 1, 2 times a negative 1 is a negative 2, negative 2 and 7 will give me 5, and if I check it and I know that a negative 5 is not on that line, which is going to be up here and not there, I know I did something wrong. So if you plot a third point and check it, you'll know you got it right. And so you won't miss out anything on your, when you do your certify in there. So you'll have your 3 points in there, and you'll know that it's crossed and it's on that spot. So try to do 3, because then you'll know that you've got your answers to work out correctly. Another thing in 4.2 they do is they give you an equation such as y equals a negative 3x. And they give you a point, negative 1 comma 3. Is this point on that line? So what you'll do is substitute in for your x. You will substitute in for y, what you're given for your y value, and see if it works. Negative 3 times a negative 1 is? Negative 3 times negative 1? What do we get? We get a positive 3. So is it correct? Yes. So it is correct, and so therefore, because it's correct, I can say yes to this, that is a point on there. But if they gave me 2 comma negative 4 and said, is that a point on this line? I put negative 4. Negative 3 times the negative 2, or times the positive 2, I should say. Is that true? Negative 4 on that side, negative 3 times 2 is a negative 6, and that's not equal. So then I would say no, that point is not on that line. Alright, so you're just substituting some stuff in to see if what they gave you is the correct answer or not the correct answer. Okay, so you got some of that stuff going on in that part too. The other big piece of 4.2 is they get into using your y-intercept and your x-intercept. Now, in the previous stuff we just talked about, what did we find out the y-intercept was? Well, the y-intercept is always x is equal to 0 and y is some value. And we found out the x-intercept is x is some value, but y is 0. So why these make our math a whole lot easier than just randomly picking points like we were doing, just picking out points out of the air. What makes these easier is if I have y equals 2x plus 7, and I pick my x and y intercept, x is 0 or y is 0, what I find is it makes my math a whole lot easier. So what does it do when I plug in 0 for x? What's my answer? Do I have to do anything? No. 2 times 0 plus 7 equals y. I don't even have to write it out because I know 2 times 0 is 0, so y is going to equal 7. So this answer right here, as long as y is by itself, will equal that number. Then if I put 0 in for y, this one's a little bit more, has more math involved in it, but not bad. Divide by 2, I find out x is equal to negative 7/2. And so that becomes my answer to this one. So that's what pops out of it. And so then if I plot those, and I end up graphing that, so on Hawks I would go at 0 at x, so I would be up at 7. And I plot this one, I'm at a negative 7/2. What's a negative 7/2? As a mixed number. 2 goes into 7, 3.
Negative 3.5.
3.5. So because it's 0, I'm at 1, 2, 3.5. So there's my 2 points, and then Hawks will draw in the line for you, and you will have your graph. So that's what your graph would look like. Then if we wanted to check it and make sure it worked, we could just put 1 in for x. 2 times 1 is 2, plus 7 is 9. And let's see if when we are at 2, we're at 9. That was up at 7. 2 up at 9, and sure enough, we are on our graph, and so therefore I know I did it correctly. Oh, 1, 9. Yep, it should be 1, 9. Yep, not 2. It should be 1, 9. Yeah, thank you for mentioning that, because it is a 1 and not a 9, and not a 2. Yep, so I'll be at 1, up at 9, and you would find out when you do this on your graph paper and your graph in Hawks, you'll see it right on there, that it comes out as a 9, and you'll know you did it right. Okay? But if you use these x-intercepts, they're very helpful. My intermediate algebra group in chapter 8, we had graphing to do in there again, and they found that if you use these, it got her 2 points quite easily. So you didn't have to come up with a whole lot of work to come up with 2 points of what you happen to graph on there. So a lot of these in this section are ones that will ask you to do that. So what if we had this for a problem? 3x, negative 3x minus 3y is equal to a negative 13. Okay, if that were my problem and I need to plot some points, I would probably end up putting zeros in here for my x, or my y-intercept. X is 0. For my x-intercept, y is 0. So I just kind of put those in my chart. So if I put 0 in for x, what's y going to equal? Negative 3 times 0 plus 3y equals negative 13. So 3y equals negative 13, because 0 is times negative 3 is 0. Divide by 3. Y is equal to negative 13 thirds. Or, what is that if I work that out? 3 goes into 13, 4 with 1/3 left over, I think. 4 1/3. Okay? And then if I put 0 in for y, I find out that I got a negative 3x, that's 0, equals a negative 13. Divide by negative 3. And I find x is equal to a positive 13 thirds. Or 4 1/3. And then I would plot those by estimating where those happen to be if I were going to graph it. So if I graph this whole thing, I would graph the first one when I'm at 0, I'm down 4 1/3. And the other one, I'm out 4 1/3. And then connect these two. And Hawks will automatically put your line in there for you. You will not have to put that in there. And then if I want to check it, I'll plug 1 in just to see what we come up with. So negative 3 times 1 plus 3y equals a negative 13. So a negative 3 plus 3y equals a negative 13. Add 3. So 3y is equal to a negative 10. So y is going to be equal to a negative 10 thirds. So when I'm at 1, I better be down at 10 thirds, which is 3 1/3. 1, 2, 3, and the third I'm kind of off again because of my spacing. But you'd probably find in Hawks that your line would be running right straight through that spot. But I'm off because of my estimating in here. It'll be more exact on your Hawks when you do that one. But in here it's a little bit off. Okay? Make sense? So really 4.2 is not a whole lot different than 4.1. It's just that you are going to be using your X and Y intercepts in there for those. Once in a while, I don't know if I can find one. They give me one in here. Oh, yes they do. This one, Y is equal to a negative X. This one comes up in your homework assignment usually, and everybody kind of looks at this one and says, huh? What the world's going on with this one? So X and Y, 0 is my X, or my Y intercept for X. 0 in for Y gives me my X intercept. So what happens? 0 in for X. So Y equals 0. Great. But what also happens when I put 0 in for Y? Did I get 2 points? Did I get 2 points? I got 1, don't I? All I have on my graph is I've got the origin plotted twice. So when you have your x-intercept is also your y-intercept, because they're identical to each other, you need to get another point. So if I put a -1 in, what happens? Y equals a negative times a -1. Now when you're substituting in, you're replacing x. You're not replacing the negative out in front. So a -1 times a -1 is a +1. So when I'm at a -1, I'm going to be up at 1. So this graph is really doing something on this order. Okay? So it's crossing there in the center, and it's giving you that type of graph. So on these, you may need, so when the intercepts are both the origin, you need to plot another point. So plot a third point. Because really you only have 1 point if they're both the same. Don't run across it too often, but once in a while that one does pop up where you've got the same stuff happening in there with those. Okay? So be aware of that so that you know what ones you got going with those. So once in a while that does happen. The other ones they give you are some special ones. These are when x equals 4 or when y equals 2. Why are they special? Notice this one does not have a y, so there's no y variable in it. This one, if you graph it, the thing that happens is that y is any number it wants to be. And x is only 4. Only 4. So what does that mean? If I were to graph this thing, what would it end up looking like? Well, it's a straight line going out here at 4, but it's a vertical line going straight up and down. So it's a vertical line going straight up and down. So it's a vertical line going straight up and down. And what leads you to going straight up and down is where x crosses at 4. If I were to do my 0 for x and 0 for y, I can't plug in 0 for, if I plug in 0 for x, do I get something that equals what it's supposed to? 0 does not equal 4, so I can't do that. But if I put 0 in for y, I can't really do that because I don't have a y. But this is where it's crossing at. So it's crossing at 4, 0. So it gives you a vertical line going straight up and down. And you just have to remember those. You can't come up with a way of plotting points with them because they're all identical with what you have. If you go to the next one, there is no x variable. And y equals 2, but x can be any number. So it's horizontal. Yep. So if I graph this one, it's going to be up here at 2, but it's going to be a horizontal going in this direction. So because it's a horizontal line, I know that it's going to go in that exact same spot. So again, if you try to do your intercept pieces with this one, y is always going to be 2. It can never be 0, so I can't have an x-intercept at all. And so it's crossing the y-axis at 2. And so you got to remember those, so this is horizontal. And as far as slopes go, this has a 0 slope. And this one has an undefined. Because it doesn't taper at all. It's going straight up and down. Straight up and down, so therefore there's no variation with it. And so you do run across those. And how they show these sometimes is 3y equals 0. So you have to divide by 3, but you find y is equal to 0, so that one would be right on the x-axis. Or they might give you 4x is equal to 16. Divide by 4, so you find x is at 4, and so it's doing the same thing as we had over there. Sometimes they put a number in front of them, so be real careful because they'll throw you off. They're the ones who kind of make mistakes. These two kind of get mixed up on which one goes which way, and you might graph it the wrong way. But again, if you got this, it's crossing the x-axis. This one's crossing the y-axis, because again, it's equal to y, and this one's equal to x. So you got those kinds of combinations in there on what you happen to have. Are we okay? What do you think? Getting x-intercepts and y-intercepts? Putting in x 0 for x if you want a y, and putting in 0 for y if you want an x that happens to come out of those. And so that's our combinations that we happen to have with those. Okay? So what about this one? We'll do one more. Y equals 1/4 x plus 2. And so if we did our x and y intercept stuff, 0 in for x, 0 in for y, what 2 points will I end up with? So if I put 0 in for x, what's y going to equal? Nope. 2. Y equals 1/4 times 0 plus 2. This 0 times 1/4 is going to give you a 0. So 0 plus 2 is y equals 2. Then if I put 0 in for y, what's x going to equal? Minus 2. But will it equal 2? Because I got that quarter out there. How do I get rid of that? By 4. Yep, negative 8, because these 4s will cancel. Leaves me with a negative 8. And then I'll have my 2. Okay? Now, if you're going to plot a third one, because just to know that you did it right, because 3 points cannot be on the same line. If it's the exact line, 3 points will make it. If it's 3 points and one's not on the line, you know you did something wrong. What would I want to pick? So I can pick anything I want for x.
Divided by 4.
Yeah, so what would you want to pick? 8, okay. So put 8 in, so y equals 1/4 times 8 over 1 plus 2. These cancel. 2 times 1 is 2. So y would end up equaling 4. So then, let me see about my graph paper over here. If I were to graph that one, just so that you can see what does end up taking place with it, because we don't have our Hawk stuff up just yet, or in our work here today. So, but what would happen in Hawks is when you would put your points in, it would end up graphing those for you. So if I put 0, when I'm at 0, I'm up at 2. When I'm at a negative 8, I'm at 0. if I connect those two, so I got a real good graph here instead of my penned in ones, what you will find is that point that we have right here will be on my graph. 1, 2, 3, 4, 5, 6, 7, 8. 8, 4. And if I extended my line out, guess I didn't draw it long enough, I would find that that point is also on my graph, and so therefore I know I did it right. Okay? So if you take the extra time to get that third point in there, then you'll know where you ended up at. Alright? Make sense?
Yeah.
Okay, and that's kind of the stuff that's in that part where you want to